29th March 1942. Arctic Ocean, approximately 60 kilometers north of Murmansk. Temperature minus 18 degrees Celsius. Wind 35 knots from the northwest. Sea state 7. Waves approximately 6 meters. Visibility approximately 2 kilometers in snow squalls. HMS Trinidad, a Fiji-class light cruiser. Displacement 8,000 tons. Engages German destroyer Z-26. The action has been underway for approximately 15 minutes. Trinidad has scored hits with her 6-inch guns. The German destroyer is damaged and withdrawing. Trinidad's captain, Commander L.S. Saunders, orders torpedo attack to finish the enemy vessel. At 1432 hours, Trinidad fires a single Mark 9 torpedo from her starboard tubes. Range to target approximately 3,000 meters. The torpedo enters the water. Motor starts. Propeller engages. The weapon should run straight toward the German destroyer. It does not. The torpedo begins curving. Instead of tracking toward the target, it turns right. The curve continues. The torpedo is executing a circle. The crew watches in confusion as their weapon curves through the water. Then in horror as they realize the circle is bringing the torpedo back toward them. At 1434 hours, approximately 90 seconds after launch, Trinidad's own torpedo strikes her starboard side, approximately 15 meters forward of the bridge. The explosion tears a hole approximately 12 meters across in the hull. Water floods into the ship. She immediately takes a 10-degree list to starboard. The bow begins settling as forward compartments flood. This is how HMS Trinidad became the only Allied warship in World War II to be sunk by her own torpedo. The immediate cause was a mechanical failure. The torpedo's gyroscope guidance system malfunctioned. But the underlying cause was more complex. Cold Arctic water, inadequate heating systems, design flaws, operational procedures that did not account for extreme conditions, all combined to create a failure mode that turned a weapon against the ship that launched it. To understand how this happened, you need to understand both Arctic convoy operations and British torpedo design in 1942. The Arctic convoys ran from Britain and Iceland to Murmansk and Archangel in the Soviet Union. They carried military supplies vital to Soviet resistance against Germany: tanks, aircraft, ammunition, raw materials. Without these supplies, Soviet forces would have been significantly weakened. The convoys were essential to Allied strategy, but the route was terrible. The convoys had to pass near German-occupied Norway. Luftwaffe bombers attacked from Norwegian bases. U-boats hunted from Norwegian ports. German surface ships, including battleship Tirpitz, threatened from Norwegian fjords. The convoys faced constant attack throughout the voyage. The Arctic environment was equally dangerous. In winter, temperatures dropped below minus 20 Celsius. Ice formed on ships, adding weight and reducing stability. Storms were frequent and severe. Waves of 10 meters or more were common. Visibility was often minimal. Ships could barely see each other in formations. Collisions were frequent. These conditions tested equipment beyond design limits. Ships were designed for North Atlantic conditions. Temperature ranged from perhaps 0 to 20 Celsius. The Arctic was colder, much colder. Systems that functioned in the North Atlantic failed in the Arctic. Lubricants froze. Hydraulics malfunctioned. Electrical systems failed. The ships were operating in conditions their designers never anticipated. HMS Trinidad was a Fiji-class cruiser. Commissioned in October 1941, she displaced 8,000 tons standard, 11,500 tons fully loaded. Length was 169.3 meters. Beam was 18.9 meters. Her main armament was 12 6-inch guns and 4 triple turrets. Secondary armament included 8 4-inch anti-aircraft guns. She carried 6 torpedo tubes, 3 on each side. Her torpedoes were Mark 9, standard British destroyer and cruiser weapon. Length 8.5 meters, diameter 21 inches. Weight 1,870 kilograms. Warhead contained 340 kilograms of TNT. Propulsion was compressed air driving a 4-cylinder engine. Speed approximately 35 knots. Range approximately 10,000 meters. Guidance was by gyroscope. The gyroscope system maintained the torpedo on course. At launch, the gyroscope was set to a specific bearing. The torpedo's control surfaces adjusted to maintain that bearing. The system was mechanical, requiring precise alignment and calibration. It was sensitive to temperature. The critical component was the gyroscope fluid. The fluid damped oscillations and maintained stability. The fluid had to remain liquid and maintain proper viscosity. In warm water, this was automatic. In cold water, the fluid could thicken or freeze, causing the gyroscope to malfunction. British torpedo designers anticipated this problem. They installed heating elements in the torpedo bodies. These heaters were supposed to maintain temperature above freezing. Electric power for the heaters came from batteries within the torpedo. The system should have worked, but the system had flaws. The heaters were inadequate for extreme cold, below -10°C. They could not maintain required temperature. The batteries providing power lost capacity in cold. At -20°C, battery output dropped significantly. The heaters received insufficient power. The torpedoes grew cold. Additionally, the torpedoes were stored on deck in the Arctic. They were exposed to ambient temperature for hours or days before use. The heaters could not overcome this cold soaking. By the time torpedoes were launched, they were already too cold. The gyroscopes were malfunctioning before the weapons entered the water. British naval procedures did not account for this. The standard procedure was to arm and launch torpedoes as needed. No pre-warming, no temperature checks. The assumption was that the heaters would maintain proper temperature. This assumption was wrong in Arctic conditions. Trinidad departed Iceland on 20th March 1942 as part of the escort for convoy PQ-13. The convoy consisted of 19 merchant ships carrying tanks, aircraft, and supplies to Murmansk. The escort included Trinidad, light cruiser HMS Edinburgh, destroyers, and smaller vessels. The route took them north of Norway, through waters where German forces operated. The convoy encountered storms immediately. By 23rd March, the ships were scattered. Ice formed on decks and superstructures. Visibility was minimal. The convoy struggled to maintain formation. German forces detected the convoy and began attacks. On 28th March, German destroyers S-24, S-25, and Z-26 intercepted the scattered convoy. They attacked individual merchant ships. The British escorts responded. Trinidad engaged Z-26. The action occurred in terrible conditions. Heavy seas, snow squalls. Temperature -18°C. Both ships were maneuvering at high speed, firing guns, attempting to torpedo each other. Trinidad scored hits with her 6-inch guns. Z-26 was damaged but still fighting. At approximately 1430 hours, Trinidad maneuvered to firing position for torpedo attack. The German destroyer was approximately 3,000 meters distant, making approximately 25 knots on an erratic course. Captain Saunders ordered a single torpedo fired. This was standard procedure. Single shot to avoid wasting weapons. If the torpedo missed, another could be fired. If it hit, no additional torpedoes were needed. The starboard tubes were trained toward the target. Fire control calculated bearing and estimated target speed. The torpedo was set and launched at 1432 hours. The torpedo entered the water normally. The motor started. The propeller engaged. The weapon accelerated to running speed, approximately 35 knots. For the first few seconds, everything appeared normal. The torpedo was running. The track was visible in the rough water. Then the torpedo began turning. Instead of tracking toward Z-26, it curved right. The curve was gentle initially, perhaps 5 degrees, but the curve continued. 10 degrees, 20 degrees. The torpedo was executing a circle. Officers on Trinidad's bridge watched in confusion. Torpedoes sometimes ran erratically due to mechanical failures, but usually they ran straight on wrong bearings or porpoised at wrong depths. A circular run was unusual, and this circle was bringing the torpedo back toward Trinidad. At approximately 90 seconds after launch, recognition occurred. The torpedo was going to hit Trinidad. Saunders ordered hard to port. Attempting to evade, Trinidad began turning. The maneuver was too late. The torpedo track intersected the ship's starboard side. At 1434 hours, the torpedo struck. The explosion occurred approximately 15 meters forward of the bridge. At the waterline, against the hull plating, the warhead detonated. 340 kilograms of TNT exploding in contact with the hull. The force tore open the plating. Water pressure at speed forced water through the breach. Flooding began immediately. The damage was catastrophic. The explosion destroyed approximately 30 meters of the starboard side structure. Multiple compartments flooded. The forward boiler room was breached. Seawater entered at enormous rate. The pumps could not keep pace. The ship began listing to starboard and settling by the bow. Damage control parties responded immediately. They closed watertight doors aft of the breach. They attempted to shore up damaged bulkheads. They pumped continuously, but the damage was beyond their capability. The hole was too large. The flooding was too fast. The ship was taking on water faster than it could be removed. Within 10 minutes, Trinidad had taken on approximately 1,000 tons of water. The list increased to 15 degrees. The bow was down approximately 2 meters. The ship was still making way but barely controllable. Speed had dropped to approximately 10 knots. The forward turrets could not train properly due to the list. Captain Saunders assessed the situation. The ship was severely damaged but still afloat. She could not fight effectively. She needed to reach port for repairs. Murmansk was approximately 200 kilometers south. If Trinidad could maintain way and the weather did not worsen, she might make it. The German destroyer Z-26 withdrew. Trinidad had scored hits on her before the torpedo incident. Z-26 was damaged and unwilling to continue action against a wounded but still armed cruiser. The immediate threat ended, but the situation remained critical. Trinidad was damaged. Listing: barely mobile. In Arctic waters with German forces nearby, the voyage to Murmansk would test the ship and crew. If the weather worsened, she might sink. If German aircraft found her, she could not defend effectively. If her pumps failed, she would flood and capsize. The damage control effort continued. Crew worked to stabilize the list. They moved weights to port side. They jettisoned non-essential equipment from starboard. They counterflooded selected port compartments. The list decreased to approximately 8 degrees, still severe but manageable. The pumping continued. Multiple pumps ran continuously, removing water from flooded compartments. The rate of flooding decreased as temporary patches were applied. The inflow stabilized at approximately 50 tons per hour. The pumps could handle this, but any additional damage would overwhelm them. Trinidad proceeded south at 10 knots. The voyage took approximately 20 hours. The crew remained at damage control stations throughout. German aircraft searched for the convoy but did not find Trinidad in the poor visibility. She reached Murmansk on 30th March without further incident. The ship was assessed by Soviet and British personnel. The damage was extensive. The hull breach was too large for temporary repair. Permanent repair required dry dock facilities that Murmansk did not have. Trinidad would have to return to Britain for full repairs, but she could not make the voyage in her current condition. Temporary repairs were needed to make her seaworthy enough for the return journey. Soviet shipyard workers and Trinidad's crew worked for 2 months. They constructed a temporary patch over the hull breach. They repaired damaged systems. They restored some combat capability. The work was completed by mid-May. Trinidad prepared to sail to Britain with convoy QP-11. The convoy departed Murmansk on 13th May, 1942. The escorts included Trinidad and several destroyers. The voyage would take them back through the Arctic, past Norway, to Iceland. On 14th May, approximately 150 kilometers north of North Cape, Norway, German aircraft found the convoy. Ju-88 bombers attacked. Trinidad attempted to evade while providing anti-aircraft fire, but she was still damaged, still slower than normal, still listing slightly. Her maneuverability was limited. At approximately 1800 hours, a German bomb struck Trinidad's port side. The explosion started fires. The damage control capabilities were already strained from the torpedo damage. The new damage overwhelmed them. Fires spread. Fuel tanks were breached. The situation became uncontrollable. By 1900 hours, Captain Saunders concluded the ship could not be saved. He ordered abandon ship. The crew evacuated to escorting destroyers after all personnel were removed. Trinidad was scuttled by British destroyers to prevent capture. She sank on 14th May 1942, approximately 150 kilometers north of Norway. Approximately 60 crew died in the bombing and subsequent evacuations. The rest survived. Trinidad was lost. The ship that had torpedoed herself limped to Murmansk, was temporarily repaired, attempted to return home, and was destroyed by German bombs before reaching safety. The torpedo failure was investigated extensively. The recovered evidence indicated gyroscope malfunction due to cold. The torpedo's heating system failed to maintain required temperature. The gyroscope fluid thickened or partially froze. The gyroscope lost stability. The control surfaces responded to false signals. The torpedo turned in a circle instead of running straight. The investigation identified multiple contributing factors. First, inadequate heater design. The heaters could not maintain temperature in Arctic conditions. Second, insufficient battery capacity in cold. The batteries providing power to the heaters lost capacity at low temperatures. Third, no pre-warming procedures. The torpedoes were cold-soaked before launch. Fourth, no temperature monitoring. Crews had no way to know if torpedoes were too cold to function properly. The investigation recommended changes: improved heater designs, better insulation, pre-warming procedures for Arctic operations, temperature monitoring systems, better battery designs for cold weather. The recommendations were implemented gradually through 1942 and 43, but for Trinidad, the changes came too late. She was destroyed partly by her own torpedo and partly by German bombs. The torpedo malfunction did not directly sink her. She survived the self-inflicted damage, but the damage crippled her enough that she could not survive the subsequent German attack. The chain of causation ran from torpedo malfunction to temporary repairs to slow speed to German bomb hit to sinking. The historical assessment is that Trinidad was lost due to a combination of equipment failure, inadequate design for Arctic conditions, and bad luck. The torpedo failure was preventable with better design. The German bomb hit was bad luck. The combination was fatal. The story became infamous in the Royal Navy. The ship that torpedoed herself. The cruiser destroyed by her own weapon. The tale was told as cautionary lesson about equipment limitations and operational procedures. Engineers studied the failure. Designers improved systems. Procedures were modified. But the underlying lesson was broader. Equipment has operating limits. Operating beyond those limits causes failures. The Arctic exceeded the design limits of British torpedoes. Using them in those conditions was gambling that the heaters would work and the gyroscopes would function. Trinidad lost that gamble. Similar failures occurred throughout the war. German torpedoes failed in the cold Baltic. Japanese torpedoes failed in tropical heat. American torpedoes failed from multiple design flaws. Every navy discovered that their weapons had limitations. Trinidad's failure was particularly dramatic because the weapon circled back and hit the launching ship. But the fundamental problem, equipment operating beyond design limits, was universal. The crew who survived Trinidad's loss had unique experience. They served on a ship torpedoed by her own weapon. They worked for 2 months to repair her in a Soviet port. They attempted to bring her home and were bombed by German aircraft. They evacuated under fire. They watched their ship scuttle. Their memories included frustration at the torpedo malfunction, anger at the inadequate equipment, pride in the repair effort that temporarily saved the ship, sorrow at losing her to German bombs after coming so close to bringing her home. The emotions were complex and contradictory. The technical details of the torpedo malfunction were preserved in investigation reports. The gyroscope fluid specifications, the heater capacity calculations, the battery performance curves at low temperature, the control system failure modes. Everything was documented and analyzed. Future designs benefited, but the human experience was less documented. The confusion on the bridge when the torpedo began circling, the horror when crew realized it would hit, the scramble to evade, the explosion, the flooding, the desperate damage control, the slow journey to Murmansk, the temporary repairs, the return voyage, the German attack, the abandonment, the sinking. These moments were lived by approximately 700 men. Most survived. 60 died. All experienced something unique. Their ship was killed partly by her own torpedo and partly by enemy action. The combination was unusual. The experience was memorable. After the war, some survivors were interviewed about Trinidad. They described the Arctic convoys as the worst service of the war, worse than the North Atlantic, worse than the Mediterranean. The cold was unbearable. The seas were terrible. The danger was constant, and the equipment failed. The torpedo failure was emblematic. The Navy sent them to fight in conditions the equipment could not handle. The torpedoes froze. The guns iced up. The radar malfunctioned. The ships themselves accumulated ice that threatened stability. Everything was harder than it should have been because the environment exceeded design parameters. Trinidad's loss demonstrated this clearly. A modern cruiser, well-designed, well-built, well-equipped, destroyed partly by equipment failure, not enemy superiority, not tactical mistakes, just a torpedo that got too cold and turned in a circle. The story deserves remembering not as humor, but as lesson. Equipment has limits. Operating beyond limits causes failures. Understanding limits and designing for actual conditions prevents disasters. Trinidad paid for inadequate design with a hole in her hull and eventual loss. The torpedo that circled back was symptom. The disease was sending ships to fight in conditions they were not designed for without modifying equipment or procedures to compensate. The Royal Navy learned this lesson, but Trinidad paid the tuition. This is the story of HMS Trinidad, the ship that torpedoed herself, the cruiser whose own weapon damaged her enough that German bombs finished her, the vessel that became infamous for a failure that should never have happened. The torpedo failure was mechanical. The loss was operational. The lesson was systemic. Equipment must match conditions. When it does not, failures occur. Sometimes those failures are catastrophic. Trinidad launched a torpedo. The torpedo turned in a circle. The torpedo hit Trinidad. The torpedo damaged Trinidad enough that she could not survive the subsequent German attack. Chain of causation from mechanical failure to sinking. The crew fought to save her. They succeeded temporarily. They almost brought her home. German bombs prevented that. But the torpedo started the chain. Without the self-inflicted damage, Trinidad might have survived the bombing. With the damage, she could not. That is the complete story. Not just the torpedo circling back, but the consequences that followed. The damage, the repairs, the return voyage, the bombing, the loss, all connected to the moment when a gyroscope froze and a torpedo turned. HMS Trinidad, the ship that torpedoed herself. The lesson in equipment limits. The warning about operating beyond design parameters. The torpedo circled. The ship was hit. The damage was severe. The repairs were temporary. The bombs were fatal. The loss was complete. That is enough to remember. The ship, the torpedo, the circle, the consequences. Trinidad, torpedoed by her own weapon, lost to German bombs, remembered as lesson. The Arctic was too cold. The torpedo froze. The gyroscope failed. The weapon turned. The ship was hit. Simple causation. Clear lesson. Bitter cost. That is HMS Trinidad. That is why she matters. That is what she taught. Equipment has limits. Exceed them at your peril. Trinidad exceeded them. The torpedo turned. The ship was lost. Lesson learned. Too late for Trinidad. But learned nonetheless. That is her legacy. That is her story. That is why we remember the ship that torpedoed herself, the cruiser that almost came home, the vessel that taught about limits. Trinidad, lost May 1942, remembered still. The torpedo turned. That is all you need to know. The rest follows from that turn. Everything. The damage, the struggle, the loss. One torpedo, one circle, one ship, one lesson. Trinidad, the ship that torpedoed herself. That is the story. Complete, clear, unforgettable. The torpedo turned. The ship paid. The lesson remains. That is enough.